In our previous lecture, we discussed about method of solving differential equation, and here is the second method of solving differential equation, which is the separating variables. Format of separating variable. If a function is given as dy over the x, here is the function of x and y. It can be separated in different form. Here is the first form: dy over dx equals to f, the function of x and the function of y. Also, it can also be given at this form: f as the function of y dy equals to f as the function of x dx. So when you add integral sign to the both equation, you can integrate and get your answer for y and the x. So here is the first problem. We need to use separating variables to solve, and we are going to use the first format in solving this problem. So let's start. Dy over the x equals to 1 plus x 1 plus y. This is the function of y, and this is the function of x, y, this is the function of y. By separating variable, the first step we need to do, we need to multiply the x through by the x. We will multiply by the x, so it will be dx times this small dot is times over dx equals to 1 plus x cubed 1 plus y dx. Where is the x we cancel out, we have dy equals to 1 plus x 1 plus y dx. While the second step, which is the separating variables, we need to separate the variables. Since y is on the x side, we need to bring it down to the y side. So it will be 1 over 1 plus dy is equals to 1 plus x dx. You can see now it's arranged. The function of y is on the dy side, while the function of x is on the dx side. So we can easily introduce our integral sign to solve this equation, which is introduce the integral sign on both sides. So we have 1 over 1 plus y dy is equals to the integral of 1 plus x dx. This is natural log. This whenever you are integrating this set, it can also be written as 1. The integral of 1 over xy can also be written as the natural log of 1 plus y. That's it. Then equals to x plus integrate plus y. That's the final answer. Hello guys, so here's the second example. We need to use separating variables to solve. So we write down the equation. Dy over dx is equals to the function of 1 plus 2y over 2 plus x. So our first step is by multiply the both sides by the x. So we multiply through by dx. So it will be dx dy over dx is equals to 1 plus 2y over 2 plus x dx. The x will cancel out, so we have dy is equals to 1 plus 2y over 2 plus x dx. So the next step, we need to separate the variable. By separating the variables, we have, so will be here, we have 1 over 1 plus 2y dx is equals to 1 over 2 plus x dx. So we introduce integral sign. So we obtain 1 over 1 plus 2y dy is equals to the integral of 1 over 2 plus x, all in brackets, 1 dx. And this will be the natural log of 1 plus 2y equals to the natural log of 1 plus y, natural log of 2 plus x plus c. So we continue. Let me just wipe here off. Where c is equals to the natural log of a, so it will be the integral of 1 plus y equals to 2 plus x plus the natural log of a, and it can also be written as 1 plus y equals to natural log of 2 plus x, where this f cancel out, have 1 plus 2. I'll just remove the parentheses with a 2 plus x. By making y solve for the formula, we obtain a 2 plus x minus 1. This is the final answer. Hello guys, so here is the third example using separating variables to solve. So we write down the equation dy over dx is equals to y squared plus xy squared over x squared y minus x squared. So we multiply by the x, so it will be the x times the y over the x is equals to y squared plus xy squared over x squared y minus, is a minus here, minus x squared the x, so the x will cancel out. We have the y is equals to y squared plus x in the bracket here, y squared bracket all in bracket x squared y minus x squared the x. So you can see that both the y, the function of y and the function of f are in one place, so we need to factor out just the y and we factor out the x, so it will be y squared 1 plus x what multiply through, you still have this equation, y half y squared times this, you have this over, you factor out the x, so it will just be y minus 1 the x. So now you can easily move the y up to the left hand side and the x will remain on the right hand side. So when this one move to the when y squared move to the left hand side to come downwards, while this one will go upward, so it will be y minus 1 over y squared. The y is equals to 1. This one remain as it is because it's not the function moving. Yes, x squared the x. This is the x, guys, the x. So this one can also be written as y over y squared minus 1 over y squared. The x is equals to 1 over x squared plus x over x squared the x. There, this one we cancel out, left with 1 over y minus, this one can also be written as y minus 2 dy. So we introduce our integral sign. So we introduce integral sign. So we have the integral of 1 over y minus y squared dy is equals to the integral of x minus squared plus 1 over x the x. So we obtain the y minus 1 over 1 equals to minus 4x minus 1 over 1 plus the x. This one can also be written as 1y plus y minus 1 equals to minus x minus 1 plus the x dx. So there's a constant. Let me just easily wipe this one off. once you integrate, you add a constant plus c, always a constant once you're integrating, minus y minus y minus y minus minus 1 equals to minus x minus 1. Okay, there's a minus, which is the minus, plus c. So you make y plus y minus 1 equals to minus x1 plus ln x plus c. That's the final answer.